Welcome, everybody. Welcome to the 4th Tulane School of Architecture lecture for fall 2021 in the series Debate, Delete, Reboot, Being Wrong in Times of Climate Change. In Times of Change. We're going to talk about climate change tonight. This lecture is a series that's meant to highlight the unintended outcomes, contrarian thinking, and humility of learning something new in the course of research and/or practice. And tonight we're joined by Professor Martha Schwartz for a lecture entitled Geoengineering Toolkit for Designers. After a presentation with Martha, we'll be joined by Professor Judith Kinnard, who's a professor of architecture in the Harvey-Wadsworth Chair of Landscape Urbanism here at the Tulane School of Architecture. Judith, of course, is a nationally recognized for impact as a leader in architectural education and award-winning designer in her own right. When I was thinking about putting together this series, Martha Schwartz was the first person that came to mind. Her entire career has been, as she defined it just a few minutes ago, on the fringe, but actualizing in her terms a new reality. And this is different forms of practice. This is doing things that people said she couldn't do on so many dimensions. And so who is Martha Schwartz? Well, she's a tenured professor of practice at Harvard University Graduate School of Design. She's a landscape architect, an urbanist, a climate activist. Her work is teaching and research focuses on the urban public realm and landscape and its importance for cities in being climate ready, if you will. For more than 40 years, she and her firm, Martha Schwartz Partners, have completed projects around the globe, from site-specific art installations to public spaces, parks, master planning, land reclamation, you name it. Professor Schwartz is now engaged in strategic land use and landscape planning and assisting leadership all around the world in preparation for the effects of climate change and for cities, and the role that cities play in both climate mitigation, adaptation, and we'll talk about today with geoengineering. Martha is the founder and participant in the GSD Climate Change Working Group. And the reason that's important is because they really set forth the first real required climate change course for students in the landscape department. And it's now something that touches really all of the required curriculum at the school, and that's extremely exciting. At the Landscape Architecture Foundation 2016, the new Landscape Declaration and the landscape architecture, Martha created not just a polemic, but a manifesto and a proclamation of change for what it means to address climate change in the practice of landscape architecture. She was awarded the 2020 ASLA Design Medal, was a recipient of numerous international recognitions, an honorary Royal Designer for Industry Award, a Royal Society of Encouragement of Arts, an honorary fellowship from the Royal Institute of British Architects, and a Council of Fellows Award by the American Society of Landscape Architects, and most recently a Doctor honoris causa from the Boston Architectural College. But let me just say this before we get into it, and we're so privileged and thankful to have Martha join us. This is the kind of contrarian thinking and the kind of way to progress through one's career that I think is a model for all of us as scholars, as practitioners, of designers, of really challenging the status quo, admitting when we get wrong, admitting when we're on a trajectory, in this case, a trajectory that fuels climate change more than it mitigates or adapts to it, and recognizing and taking the leadership position to really change the conversation and finding some humility and some inspiration along the way. So for that, for both the inspiration part, I'll turn it over to Martha.
Geez, Jesse, I hate to tell you this, but you got the wrong Martha Schwartz. Seriously. But thank you for all that. That's like, wow. Okay, I'm going to try to pull myself together and start here. We are going to talk about climate change. It is a real honor to be here, and thank you for inviting me. I've been looking forward to this for quite some time. I'm going to start by just trying to go through things very quickly here. My background isn't fine arts, and I always intended to be in fine arts, and I went into landscape architecture, not to be a landscape architect, sorry, but to actually make land art. These were my heroes. And after I graduated, I got out of graduate school. I spent 1 year at the GSD, but my first project was a bagel garden. It was a garden made out of bagels. And it was sort of a joke, and I played on my then husband, since we disagreed about how to design this tiny, tiny little teensy yard in Back Bay, Boston. This is Peter Walker, the landscape architect in the United States. And he left for a business trip for a week. And I did an installation with the idea of spending about $50 to buy whatever I could find around our block. So I bought around 70 bagels, purple fish gravel, and some purple flowers I can't remember the name of. So I threw a garden party with about 15 friends where we waited until my husband arrived. When he did, he was not impressed and went straight into the house. However, one of my friends suggested that I send some of the pictures that were taken to the American Society of Landscape Architecture, which I did. And the editor, Grady Clay, decided to put it on the front cover and asked me to write about why I did this. So in the 1990s, a million years ago, the profession was mostly white, male, and very boring. And they were focused on design being appropriate, which of course is like a red flag when you put them in front of art people. So I wrote a short paper about why the bagel is appropriate. It's inexpensive, anyone can do it. They do well in the shade, they don't need water, and they are biodegradable. So this, to my point of view, makes a bagel an appropriate landscape material. That really freaked everybody out. I mean, Grady Clay got sacked, people stopped getting the magazine, but on the other hand, there were a lot of younger people who were like, hey, this is very cool, maybe we can do different things than grids. And anyway, I was too young to actually feel like, whatever, but coming from the art world, it was clear that landscape architecture was just boring. So what this was like was the Marcel Duchamp's toilet in the museum. He anonymously submitted this work to the Society of Independent Artists Salon in 1917, and it was immediately rejected and became instantly famous. So that's what this was. I didn't intend to become famous, I'll tell you that. The piece questioned whether an artist must make an object in order for it to be considered art, or whether choosing it and calling it art could be enough, thereby significantly altering the role of the artist. This changed the art world forever in terms of the perception of what art could be. So, I mean, I kind of knew about Duchamp, but I was just like, I had nothing to lose. I was going to do this bagel garden. So I'm going to go through these projects super quickly, not talk about them. I'll just say kind of where they are. This is the Dublin Dockland Opera House. And this is just kind of a party outside of it. This one it's called Beijing. It's a mixed-use development in Beijing. It has all different kinds of parts about this. This is a children's playground. This is Yorkville Park in Toronto. Also Yorkville Park, it's a very well-known park now. This is a public park in Chongqing, China. At nighttime, it looks great, but these are lanterns. Next is a 500-acre regenerated clay quarry that we actually regenerated a huge, ugly clay pit and reshaped it. And now it's really flourishing. Yeah, along with the gumdrops. Let's see, this is a Mesa Center for the Arts in Arizona. Again, kind of, it's a raw, like an interior street that is just for pedestrians inside this cultural center. This is the Vanke headquarter building in Shenzhen in China. Next, here we go. And then we have Exchange Square, which was an area that was bombed in Manchester, and they rebuilt it. This is the fountain. That people love to actually walk or sleep on or bicycle ride on. This is Yangguiqing Grand Canal Cultural Park in China. It's a large afforestation master plan. And let's see. Yeah, I won't go into it. So, I mean, we do big master plans, we do bigger projects, we do art installations, kind of everything. And then in 2011, we were one of 9 international landscape design firms to be invited by Xi'an in China at the International Horticultural Exposition to design a small garden installation on the theme of the harmonious coexistence of nature and city. And now it's a permanent installation for a long-term development of the site. So it's all about concrete, bricks, mirrors, and trees that only you see the top of it. The tree is basic. The trees are actually the ceiling. And then you go through this maze, basically, you end up looking into an infinite forest. So it's a play on mirrors. This one is the Abu Dhabi Al Soas Square. It's a stock exchange in Abu Dhabi. And what was interesting about this is that it was a roof deck, couldn't hold anything. So everything is made out of plants that can grow on almost like panels, so that we could make mounds and shapes. I won't go into a lot of this stuff. This is a Gifu public housing that Isozaki was a master plan for. And this is, of course, this is Place de Republique it was interesting. I mean, it's a very historic place, and we had to kind of keep the trees going, but yeah, it's turned out to be very, very, what we actually did is we closed the road so it could be attached to the neighboring neighborhood. And now it's very, very full of people, which is great. So this is a little garden in El Paso, Texas, which is about kind of making a little city of individual gardens and about space. Each room was somehow about the landscape. And then this is the Zhejiang China Waterfront Park. It also is dealing with a lot of stormwater and water coming down from the top of the hill and making sure that it was cleaned before it went into a completely polluted river anyway. And it's really turned out to be extremely popular. Okay, so I mean, that was just to give you some street cred, but here is the beginning of kind of my turn of events. And in 2016, I quit the profession of landscape architecture. And what happened is my sister sent me a YouTube of Professor Peter Wadhams from Cambridge University, who's a renowned Arctic expert. And he explained how the warming of the Arctic Ocean was melting the permafrost on the eastern Siberian Arctic shelf, which is releasing methane, which is a very potent greenhouse gas. And I kind of looked into it. Methane is like 25 to 30 times stronger greenhouse gas than carbon dioxide, and create a vicious cycle loop that speeds up the rate and the amount of heating. So I really did freak out. I mean, there are these calthrates that bubble up from the bottom of the ocean that are kind of exploding the stuff into the atmosphere. So I was completely distressed. I actually called up Peter Wadhams. I introduced myself as a landscape architect, and I knew nothing about climate change, but I actually wanted to help somebody who did know something about climate change because we needed to kind of deal with it. And I offered to do office work for him. I could be a gopher, or I could type, or something like that. And he laughed, but not actually at me. And we really became friends. And I learned quite a bit about what he was doing, its relationship to climate change. So I was, and I still am, distraught about delivering such a world to my 3 beautiful children. I participated in this. I I really have a hard time thinking about what our future may bear for this next generation. So I stopped really working in my own office and started a deep dive learning about climate change by reading lots of readable books that are by very good climate writers. And I was desperate to find solutions because I'm very solution oriented, because as you know, having an office, everybody's coming to you with a gajillion different problems that you then have to somehow solve. So I came across 2 or 3 books that opened up the topic of geoengineering, and with these really interesting ideas about how to actually interface with the climate to actually make changes in it. And I was just hooked by it because there were so many kooky, wacky, weird ideas coming out. Of course, it attracted me as a designer. So I ended up teaching a seminar called Beyond Adaptation, Designers Geoengineering Toolkit for Mitigation, with the intention of teaching a bit of climate change and about the larger scale solutions that are coming out of the science that we can actually learn from and integrate into the design process, which I should show you, but we are already doing that. But, you know, actually I am still freaked out. The more I know, the worse it gets. That's the problem. So where are we now in climate change? This is a graph of the heat projection scenarios, and it's my own interactive graph that I play around with. And temperature on the y-axis is and time is on the x-axis. The black line is the RCP 8.5 business as usual scenario, which is always the worst case scenario. So current graphs now show that we have actually exceeded 8.5 since we are putting out more carbon dioxide than we're taking it down. At least this is a projection of 2021. Now, the red dots show where we are now, which is at 1.1 degree, maybe 0.2 degrees centigrade. And by 2050, it's likely that we will be at 2 degrees. And by 2100, if we continue on the way we're doing, which I'm hoping that we aren't, I have some hope, we may be at 5 degrees, which actually it's game over for humans and practically everything else on Earth. So global ocean temperatures are now about 1 degree higher than 140 years ago. Now, that's not a lot, but just imagine how many sticks of wood you'd have to actually heat up all the oceans in the world, a lot. Sea level is rising faster than predicted. And based on preliminary analysis, the global average atmospheric carbon dioxide in 2020 was 412.5 parts per million, setting a new record high amount despite the economic slowdown due to the COVID-19 pandemic. So we're not doing great. The Amazon forest is actually losing its capacity to fight climate change and is putting up more carbon dioxide than it's taking down. Climate change along factors like land degradation and habitat loss is a top threat to wildlife around the globe and causing some animals to decline by as much as 50% by the end of the century, and up to 90% of coral reefs in the Pacific Ocean may bleach or degrade by the year 2050, which actually is not good at all for us. And overall, it is estimated that half the globe's 5,491 known mammals are declining in population, and a fifth are clearly at risk of disappearing forever. So with about 1,000 mammals across the globe classified as endangered, threatened, or vulnerable. In addition to primates, marine mammals, including several species of whales, dolphins, and porpoises, are among those mammals slipping more quickly towards extinction. And the one thing that really is a problem is at the very bottom of the food chain, which are the insects. Those are disappearing. And once the bottom of a food chain starts to disappear, everything on top of that food chain actually starts disappearing too. So let's just quick talk about the coral reef die-offs. Up to 90% of the corals may bleach, as I said, will bleach or actually be dead by 2050. The thing is that I didn't realize is that 50 to 80% of the Earth's oxygen is actually generated by the coral reefs, but basically it's by the biota that is dependent upon the reefs. So I'm a little concerned because the other, 30% of our oxygen is coming out of forests that are being deforested. So yeah, I mean, it could be difficult for us to actually get oxygen in the future. So let's briefly talk about New Orleans and Louisiana, where you guys are. New Orleans, I'm sure you know a lot about this, probably more than I do, but I've really been, of course, I read about it all the time, but it's on the front lines of climate change. And while New Orleans is no stranger to hurricanes and warm temperatures, the effects of climate change are becoming a regular part. Not only that, there are tornadoes and marsh fires and extremely hot days. The air quality alert days and flooding are occurring more frequently in addition to sea level rise. So the impacts that you're feeling are like most of the world, and it's already seeing signs of climate change, and these impacts will only continue to get more severe in the future. Currently, climate researchers are projecting the following impacts on New Orleans. Rising temperatures and an increase in extreme heat days. New Orleans is the 15th hottest city in the United States, and 160,000 people are living in vulnerable areas. Louisiana averages about 35 days a year when heat exceeds dangerous levels. And by 2050, the state is projected to average nearly 115 danger days a year. Also, Louisiana is projected to see one of the nation's largest increases in heat waves by 2050. So it's hot, hot, hot. There'll be changes in annual precipitation with more extreme precipitation events. And Louisiana is also known for losing its battle against rising seas and increasingly frequent floods that we read about all the time. And it can sometimes seem like the state has too much water, but actually this is interesting, and I didn't know this, but the aquifers deep beneath its landscape faces a critical shortage due to overuse, unregulated pumping by industries and agriculture, and the scant oversight or action from legislative committees that are full of conflicts of interest and probably graft also. So sea levels in New Orleans are likely to increase by 1 to 4.6 feet by 2100, based on estimates of absolute sea level rise. And these conditions give much of Louisiana's coast a relative sea level rise rate that is among the highest in the nation. Of course, honestly, we're not exactly sure about sea level rise. It all depends about how much water is melting from ice shelves, how much water is running out from melted glaciers. Anyway, like everything else, we're not quite sure about everything. So there'll also be an increase in vector-borne diseases in Louisiana. And of course, the mosquito is one of the most important and prevalent vectors, which thrive in warm and humid weather. And there'll be a possibility of more spread of dengue fever, West Nile fever, and Zika. So that's kind of on the rise as well. So the rising temperatures are a real problem in terms of the air quality, and greater air stagnation and wildfire emissions during dry periods will increase particulate matter in concentrations. Also, ozone and particulate matter cause a decrease in lung function and an increase in the hospital or emergency rooms visits with asthma. This was interesting when I really read about it, and you guys probably all know about it, is Cancer Alley, which is the area along the Mississippi River between Baton Rouge and New Orleans in the river parishes of Louisiana. And it contains numerous industrial plants, and it has a cluster of cancer patients that have been covered a lot by news media, leading to the Cancer Alley moniker, the name of Cancer Alley. And it's known as a sacrifice zone. So that's just still sitting there. So there are about, you're on a confluence of a river delta and the ocean. And there are about 20 major delta cities around the world that are dealing with both sea level rise and land subsidence, like New Orleans is. along with severe subsidence, along with New Orleans. Now, most of these deltas are in countries of the global south. There are more countries with these issues, which are suffering the impacts of global warming, more so than the countries of the global north. And while what is happening in New Orleans is basically a tragedy, there are many people in the world who are suffering different effects of climate change, such as what New Orleans is facing. So what you have in common with the global south is that the effects of climate change is happening sooner than most of the areas in the global north. And we're going to look into the global south, which is the largest case of environmental inequality in the world. And due to the catastrophic flooding, New Orleans has also experienced the inequality of climate change effects. So the global south is a term often used to identify lower income countries on one side of the so-called global north-south divide. The global south countries that are least responsible for causing climate change are the ones suffering most from its effects, especially regarding food insecurity and nutrient deficiencies. Scientists warn that we need to act now. So in the north, 25% of the global population owns 75% of the global wealth. 86% of manufacturing industries are owned and located in the global north. And inversely, the south, with 75% of the world population, has access to 27% of the world's global wealth. This is actually, this is a big case of global inequity. I mean, huge, I guess, from Donald Trump. So Earth is heating up from the south to the north, which puts the global south in the front lines of climate change, as these countries are closer to the equator and the climate is heating up there more quickly than the northern hemisphere. The people in the south are experiencing now greater threats and suffering much more than we in the north, except for you guys. And in New Orleans. And I believe that we global northerners must find ways to help them, as we are responsible for what they're facing. Now we're going to go on a little trip. We're not going to hit every country of the global south, but it's very important for us as global northerners to really understand what is happening in the rest of the world. We tend to be, as Americans, highly xenophobic and phobic, and we don't really have a lot of news of what's happening around the world, but a lot is happening around the world. And Africa is one of the countries most affected by severe heat. An annual temperature increase for much of Africa is projected to fall within the range of 3 to 6 degrees by the end of the 21st century, if the emissions continue to occur. And the rising temperature is likely to lead to deaths, displacement, climate-related conflict, irregular rainfall, drinking water shortages, and the decrease of agricultural production. It's an agricultural-based continent. The frequency, intensity, and duration of extreme heats are expected to increase. Climate change is an increasing threat to Africa, and they are already experiencing rising levels and coastal erosion, extreme weather events. And this is a map, fuzzy map, that shows deaths attributed to climate change in the year 2000. Africa has clearly suffered by far the highest percentages of deaths. Agriculture, as I said, is the backbone of Africa's economy and accounts for the majority of livelihoods across the continent. Global warming will challenge food security big time, and risks of warming on agriculture include reduced crop productivity, increased pest damage, disease damage, and flood impacts on food system infrastructure, resulting in serious adverse effects on food security in livelihoods. There's going to be a lot of starvation going on. And food security is endemic to almost all global south countries. These are all pictures taken from an article about the 10 most hungry countries in the world. And the large majority who suffer climate change impacts by far are women and children, by many times over. Okay, so what about India? What's going on there? India stands to be one of the nation's most significant, the world's most significantly affected countries, given its huge population and levels of inequality and poverty. India is already experiencing severe and increasing heat that will disproportionately affect disadvantaged and vulnerable populations. In 2015, a heat wave killed thousands of people in India and Pakistan and could soon become the norm. And due to multiple effects of climate change, access to food is collapsing. Tropical cyclones will bring widespread flooding across the south, causing deaths affecting 1.8 million people, and rise in sea level will affect a total of 36 million people in the country by 2050. Worldwide, rising sea levels could, within 3 decades, push chronic floods to affect 300 million people, according to the research by a New Jersey-based science organization called Climate Central. Groundwater makes up 40% of the country's water supply, but other sources are also running dry. Almost 2/3 of India's reservoirs are running below normal water levels, and Prime Minister Modi promised to provide pipe water to every rural home by 2024, but many fear it won't be enough due to the fact that many people can't afford the cost and they have to pay for it. So, when people show up needing water and food, it's non-negotiable. It causes social instability. Water supply is a huge concern in India and China. And social instability is being caused due to meltwaters that are releasing too much water and then running dry in India. So the longstanding border tensions have been ramping up and erupted between China and India last June, leading to the first deadly conflicts between the two nations in decades, but it's building. And the Tibetan Plateau is home to the largest store of fresh water outside the North and South poles. The Himalayas cover about 25% of China's surface, and it is the source of some of the world's great rivers, such as the Indus, Ganges, Brahmaputra, the Mekong, Yangtze, and Yellow River. And the meltwaters of the Himalayas feed these waters into countries such as China, Pakistan, India, Bangladesh, and South Asia's other major rivers. And the precipitation in this region is critical to water resource in the Indian subcontinent. However, the Himalayas are among the most impacted region in the world by recent climate change. And temperatures are rising faster than anywhere else in Asia on this plateau, and has experienced rapidly increasing temperature and decreasing monsoon precipitation. So not only is it melting, but there's less water falling and less ice being melted. So at least 1/3 of the huge ice fields in the Himalayas are doomed to melt due to climate change. And these glaciers provide water for agriculture, hydropower, and household uses as they melt every year. And the loss of the Himalaya glaciers will drastically affect China and all the surrounding countries. So 36 to 66 of the glaciers will be gone by 2100, even if we stop at 1.5 degrees. And the vivid transformations on the Tibetan Plateau have important ramifications, not only from China, but also for the rest of Asia, as climate patterns change across the continent and fragile communities are threatened. And the melting glaciers could affect over 2 billion people. So the authors of this document said that people will be displaced more than 4 times the prediction of earlier reports. So the things are really even getting worse. Now, and by 2050 or 2060, they also estimated that 1.4 billion will be displaced looking for food and water. So that's coming up pretty quickly, and we're already starting to see big climate migrations. So that's all bad news, right? But wait, there are more problems to actually talk about. So let's talk about tipping points that are happening globally. And potential tipping points have been identified in the physical climate system and impacted ecosystems, and sometimes in both. And we don't know the precise point when these natural systems will move to abrupt change. We may not reach some tipping points for a long time. However, we are experiencing the tipping of the tipping points now, and maybe on a pathway that are in the process of leading up to abrupt change. Again, this is happening now. Now, this is a nice little kind of map of different tipping points that are happening across the world. I would say that my freakouts are the Atlantic circulation slowdown, which is the actual slowdown of the circulation that goes from the northern hemisphere to Europe, which is very, very warm. It's the Gulf Stream. And once that actually starts to slow down, all sorts of shenanigans in terms of climate, like, you know, freezing Europe or too much rain, but it is slowing down. And the other thing is the loss of boreal forests. The coral reefs, as I said, you know, it's going to be tough living without oxygen, and the thawing permafrost, which I still am freaking out about. So there's a growing concern as the Arctic is heating up 5 times faster than the rest of the globe and melting the permafrost, and more methane is escaping. And these tipping points are tipping, and the IPCC even says that methane reductions are probably the only way of staving off average global temperature rises of 1.5. So if the IPCC is complaining about it, I guess it's legit. So we've fallen short of goals. On top of this, the international goals shaped by the Paris Climate Agreement has not been reached. Hopefully COP26 has set out new goals, but probably not enough. And hopefully these will be met this time. But trying to project what the global leadership is going to do in the future is a risky business. Also, there's no amount of adaptation or planning that can lead us to a secure climate future. This is an interesting one. Arnulf Grubler is a professor of technology and systems analysis who studies energy transitions and concludes that they have been very, very slow. So the idea of transitioning over to an electric-based energy could take a bit of time, you know, 30 years, 50 years, 75. I don't think it'll be later than that, but we still are going to have to take the time to actually transition to renewable energies. So yeah, this is the Gulf Stream that is starting to slow down, and it could actually increase the warmth, and therefore Greenland would start melting again, and tropical monsoon patterns would shift, and rainfall in northern hemisphere, where I am, would decrease, and the North Atlantic would get stormier. So it also raises concern, and that's the thing about these tipping points, is these tipping points can actually tip other tipping points. It's kind of a mess, and honestly, nobody quite knows exactly when tipping points start tipping or going to end tipping. So there's a lot of anxiety on the tipping points. So why is the climate change 2 degrees Celsius warming limit so important? It often mentions, you know, the articles that we will be risking catastrophic impacts by 2 degrees, because we're also now experiencing catastrophic impacts. And recently, a series of scientific papers have come out and say that we have I hope this is wrong. So let's just say you have to be careful about what you're reading, and you have to find out what the resources are. But this one, let's just say it's wrong, but it says that we have a 5% chance of limiting warming to 2 degrees, and only 1 chance in 100 of keeping man-made global warming to 1.5. And we already may have locked in 1.5 of warming, even if we magically reduce our carbon footprint to 0 today. Unfortunately, I've seen these metrics before. I'm hoping that those are also wrong. Yeah, so I still continue to be very worried, maybe even double worried, like what else could go wrong? And if we stop emissions today, this is a really important, I wish I could see everybody's hands, but think about what you think about this question. If we stop emitting carbon dioxide today, would the Earth stop warming? Would we have actually dealt with the issues of climate change? Does that really put us in a place where we want to be? Will we be back to a stable Earth? Unfortunately, the answer is no. The Earth would continue to warm up for a decade, if not more, until the Earth reaches some kind of planetary equilibrium, but we would never come back to where we were or we are now. One of the issues is called committed warming, which is caused by the absorption of heat from the sun by the Earth and the oceans, and it takes around 40, maybe 50 or 60 years for this warming to actually escape from the soils and the oceans back into the atmosphere. However, this heating is not included in the IPCC's metrics, so we somehow have to add that 1.4 degrees centigrade into the recent 1.2 degrees. So another problem is that the Arctic ice cap reflects heat back out due to its high albedo. It's white and shiny, but since it has been melting, the increasing surface of the dark ocean is getting larger, which is absorbing more heat because it's lost the albedo. It doesn't have a high albedo, which is released into the atmosphere, thereby raising the overall temperature. I love this one. This is a huge problem that we have, which is a giant blanket of 1,500 or so gigatons of atmospheric carbon dioxide sitting on top of us, a thick blanket that's covering us and trapping the heat. And this is a data visualization from Richard Weller, who is the chair of the Landscape Architecture Department at the University of Pennsylvania. And this is Mount Carbon. Mount Carbon shows all of the carbon dioxide stacked up. And it's 10 times higher than Mount Everest, which is at the bottom of the page here. David Keith says, who is a Harvard physicist and environmentalist, he writes, quote, "Carbon casts a long shadow onto the future. 1,000 years after we stop pumping carbon into the air, the warming will still be about half as large as it was on the day we stopped," unquote. Meaning that in human scale life, it's up there forever. And the only way that we're going to get it down for us quickly is to take it down through machines and geoengineering. So the other kind of strange possibility here is that, according to this research paper, crossing into a hothouse Earth period would see a very much higher global temperature than at any time in the past 102 million years. And the climate might stabilize by 4 to 5 degrees of warming, although a lot of us won't be around. The seas could be 30 to 180 feet high. Parts of the Earth could be uninhabitable. I mean, this is kind of a mega tipping point kind of thing. The article says the following, that even if countries succeed in meeting their carbon dioxide targets, we could still lurch into an irreversible pathway. And according to the authors of this paper, the current plans to cut carbon may not be enough if their analysis is correct. So in one sense, there's a lot of uncertainty. It's nice and cozy to look at the IPCC, who kind of give us this information, but science and kind of in the time of climate change is really, we don't know exactly where these things are going. And the problem is also that most of it depends on what humans do, which is also not really knowable. So the problem is, how do we stop global warming? And this is a very important, but I believe it's an overlooked piece of the climate change dialogue, except for the scientists. And the scientists have been working on this issue of global warming for half a century, if not longer, since they knew what was coming our way for a long time. And this is what we're going to look after next, is about global warming. So I've been thinking this through, and that for whatever reasons, the information that we are getting has avoided the issue of global warming. And I want you to think about this for two reasons. More people need to understand what the scientists are saying. We have to actually have enough information where we can at least understand what is coming out of science and not depend quite so much on the IPCC, which has its own agenda. I know I sound like a kook, but they're really trying to figure out what we need to do in very simple ways across the world. So some of this stuff seems to get left out of that dialogue, and it's up to us to actually look at the conversations that scientists are having. And scientists do say, and do talk about, what is coming our way, and they've known about unchecked global warming. And the reason is that there's only one possible solution which can possibly check runaway global warming, which I'll get to. And the other one is that the profession of landscape architecture, as opposed to other professions of the built environment, can address both of these problems. We draw down carbon dioxide because of our management and design with natural systems and greenery, trees, and as well as soils, because soils actually take down a lot of carbon dioxide, and this is really part of our remit. And also, it can cool the environment through the deployment of nature-based solutions. So we are a very, very instrumental part of solutions in climate change. And this is why I thought it was very important for us to start teaching geoengineering to the students at Harvard, because not only are we learning about climate change, but we're learning about not only ecology, but we're learning about the scale of Earth's systems. So it's super important. So what kind of future are we going to choose? And policymakers have missed a critical problem. And how do we stop global warming? That's the topic we're going to talk about now. So policymakers must assure that our next generation's future will be safe. And we have to look at options that can not only reduce emissions, but will counteract the effects of global warming. So what is it that we actually need to do to create a stable and safe climate? We actually have to do a lot more than just reducing our emissions. And this is where we, as builders of the built environment, we have to understand what else needs to be done. We have three other important things to do, which are, number one, draw down atmospheric carbon dioxide to cool down the planet, lower the Earth's temperature, and we have to regenerate nature, because that is our problem, is that we've kind of forgotten that we're attached to nature, and that we have to regenerate its systems so that we can actually keep on keeping on as a as humans. So how do we ensure a safe climate? This is a case for climate intervention, commonly referred to as geoengineering, which is a deliberate and large-scale intervention into the Earth's climate systems. And as our planet enters a period of changing climate, never before experienced in recorded human history, interest is actually growing in the potential for deliberate intervention in the climate system to counter climate change. And climate intervention studies have two major subjects. One is carbon dioxide removal and addressing global warming by cooling down the Earth. And the other one is carbon dioxide removal that we just talked about. So I'm going to explain how we may be able to survive the crisis if it does become a full crisis through a geoengineering method that has actually been discussed since the 1940s, called stratospheric aerosol intervention. It's called all sorts of things, but it's an important idea that I myself am very, very interested in. So let's take a look at how carbon dioxide removal and actually solar geoengineering are related to each other. The carbon dioxide removal deals with the carbon cycle, and the solar geoengineering deals with the energy cycle by tamping it down or trying to. However, as is everything in nature, they are closely connected to each, as carbon dioxide, a greenhouse gas, is trapping the heat and causing global warming. This is a simplified idea or graph or data visualization, but these interactive systems are actually what is causing the climate to heat up and therefore causing all the effects. And since these are two different systems with very different properties, they therefore need their own platform for research and development. And while carbon dioxide removal has been funded and has made great progress, there has been next to no funding for research on how to deal with global warming and stratospheric aerosol injection. And this creates a lopsided approach to climate change solutions, as both of these cycles need to be affected through climate intervention. And to develop one method that can get us back on track, and without one not being researched or not being used, we will not be able to meet the risks of climate change. One is attached to the other. So what people don't fully appreciate is that we've already geoengineered the planet, but we didn't know we were doing it. So we're kind of reverse engineering the planet, actually. And most scientists consider we will have to employ geoengineering technology if we want to avoid the worst case scenarios. And the possibility of using geoengineering is deeply, deeply controversial. Now, what is it? What are the components of it? There's a wide range of technologies and practices that are considered under the umbrella of geoengineering. The one consistency is that these solutions are geoengineering solutions because of the scale at which they interact with the climate. Geoengineering has, as I said, two major arms. The solar geoengineering, also called solar radiation management, the purple ones, and carbon dioxide removal, or the blue ones. But first, we're going to talk about carbon dioxide removal quickly, which are based on chemical, physical, and land-based methods. So many of them, pointed out by the green arrows, including the coastal blue carbon, accelerated weathering of rocks, afforestation, and soil carbon, are relevant to landscape architecture. And actually, we are using some of these things in our practice. Landscape architecture, urban design, and planning are an extremely relevant practices that deal with carbon capture and land management of natural systems. We have to know about that. We won't be able to discuss all these methods and technologies, but we'll talk in a bit of depth about direct air capture and afforestation. So here we are in the carbon dioxide removal group, and we're really going to be looking at direct air capture, which is in the physical and land-based methods. So I'm sorry, it's not land-based, this is just physical. Next one is land-based. This is a fuzzy direct air capture machine that sucks out carbon dioxide directly out of the atmosphere. What happens is, this is not it's a diagrammatic kind of description of it. Fans suck out the air through a process, through fans. The process that it goes through actually separates the carbon dioxide from the air, mixes it with hydrogen, and it's then compressed and made into a synthetic zero emissions fuel. So this can be used for long haul transport by airplanes or shipping, which are both difficult sectors to decarbonize, but at least now it will be able to continue, but it will have a zero emissions because of the ability of reducing the amount of carbon dioxide in the fuel. This is another direct air capture plant in Iceland called Climeworks. And in the last few years, direct air capture has become an important part of the climate change discussion that is extremely important. It's needed to extract atmospheric carbon dioxide. It's important that it is actually sequestered in the ground, which I'll talk about. It's important that it produced a zero net emissions oil, and it can incentivize carbon taxing because it can be monetized. And the great thing about this plant is that it's powered by geothermal energy. It draws down the air, renewable by renewable power, and is then pumped into, it's actually then almost liquefied, and then pumped down into the basalt, which is what Iceland is made of. And there are only a few types of rock that bond and mineralize with the carbon dioxide so that it is permanently taken out of the atmosphere, which is considered sequestration. Sequestration and carbon dioxide capture are two different things. By the way, trees do not sequester carbon dioxide, they capture it. But as of all living things on Earth, once we die, we let our carbon dioxide back out into the atmosphere. It is a cycle. So under the arm of carbon dioxide removal, there is a section called natural carbon dioxide removal. And this is the wheelhouse of landscape architecture, working with plants and soils which naturally absorb carbon dioxide. We are the decarbonizing profession. So the other carbon dioxide removal we're talking about is the natural carbon dioxide removal based on land-based methods. Now, let's talk about nature-based solutions. It's kind of a new idea, which should become mainstream land management strategies. And the idea is that these provide solutions for restoring ecosystem services, which directly feed into the realization of the Sustainable Development Goals of the United Nations. I hope everybody knows what ecosystem services mean. And they will be key to rebuilding our cities to become climate ready, more resilient, more self-sufficient, sustainable, healthier, and happier. And the new urban landscape for the era of climate change is something I would love to talk about. However, I'm afraid that to really go into deep, it would take a little bit more time. Now, green infrastructure is defined as an interconnected network of open green spaces that provide a range of ecosystem services, thus creating healthier environments through landscape projects that deliver a sustainable return on investment. And this is a list of the elements within cities that are functional as infrastructure that can protect cities from many impacts of climate change. I can just say that this morning I had a lecture in Dubai, and I pushed against their master plan because every time they talked about going green, they talked about taking down emissions. And I was like, you're never going to go there unless you figure out how to green your city and deal with the heat and the too much water and the food and the lack of water. Dealing with regreening cities is absolutely essential. So, I mean, these are all the different kinds of benefits that greening cities and urban afforestation can do for us. I mean, it'll take forever to go through it, but stormwater management, I'm actually working on a research project at Harvard about urban afforestation and dealing with stormwater management and really being able to build different kinds of infrastructure and get away from centralized infrastructure, which cities don't have enough money to be able to redo because they're all too old. So we need to think about how we're going to have different ideas about urban infrastructure. And we have to include the landscape in that. Otherwise, it won't be good. And drawing down carbon dioxide, what happens is that plants actually attract clouds by creating more moisture. It improves soils, improves biodiversity, which we need. It cools, it cleans air pollution. And just to continue on, it really deals with human health and actually mental health, creates a lot of monetary values. It reduces energy needs by a lot, absorbs flood water, wind protection, sun protection, improves quality of life, and it's beautiful. So this next idea is fantastic. And it's about talking about a more robust and radical approach, which is to rewild our cities by inserting functional ecosystems. In other words, ecosystems are connected cycles, just like the Earth systems and ecology. And that's what actually provides the most benefits. So how do we actually not go to street trees, which are not connected to anything and don't really provide much of anything? How do we start actually understanding ecological processes and put them and find the space in cities? That's what we got to do. But that means Well, I'm sorry, I pressed this. Yeah, but what that really does mean is that we actually have to find more land within our cities to be able to put these green solutions into them. And I would say the best planner in the world is Tom Adams in Melbourne, Australia. And I'm sorry, not Tom, Rob Adams, his name is. And he basically greened Melbourne over the last 20 years, which is sitting right on the edge of the desert. And it has been an incredible renaissance for that city, because everything you can possibly green is green, meaning it's cooler, it's attracting water, it's beautiful, you know, it's really created, let's say, life in the city. Okay, so now we're going to look at the Solar Radiation Management Group, and specifically at Stratospheric Aerosol Intervention, or SAI. Here it's called injection. The scientists couldn't figure out a worse name for this, but you know what? Scientists are not great communicators, so that's one of my jobs, is to try to communicate out what they're doing, because yeah, they come up with names like stratospheric aerosol injection. Nobody likes injections. So solar geoengineering, which is what this is, refers to proposed approaches to cool the Earth by reflecting solar radiation back to space. But they pose risks, challenges, and uncertainties. And however, there is a building scientific consensus that we may need such methods to cool down the Earth due to, again, many reasons. There are quite a number of different kinds of solar geoengineering methods, all of which are about increasing the albedo in order to reflect the sun's rays back out into space and cool the Earth. And ideas about using aerosols in the atmosphere to cool the Earth came out of a scientific exploration of why volcanoes cool the Earth after an explosion. And the cooling happened because large amounts of sulfur aerosols reflected incoming sunlight and thus cooled the planet. So in order to mimic the volcano, we need to get the aerosols up into the stratosphere. Planes would spray the aerosols, carefully controlling the rate of its release, which would remain aloft for a year, making them more effective at reflecting sunlight. Eventually, the aerosols fall to Earth in a harmless form of sulfur dioxide, if we actually use sulfates as aerosols, so that needs to be determined. And research has confirmed that it would take less than a year to have an effect on climate once it has been deployed. It will require continued treatments to the stratosphere, and once started, will need to be done for decades, while carbon dioxide removal and weaning off hydrocarbons get the climate under control. And at that point, SAI would need to be very gradually discontinued to avoid a massive rebound or reheating up of the Earth too quickly. It has been reviewed and analyzed by the Royal Society Report, the world's oldest independent scientific academy dedicated to promoting excellence in science. And in this report, they say, SAI would reduce the effects of global warming and its associated risks effectively, globally, rapidly, reversibly, and inexpensively. It also seems to be technologically feasible. A few grams of it in the stratosphere will offset the warming caused by a ton of carbon dioxide. And even the amount that would be needed by 2070 is dwarfed by the roughly 50 million metric tons of sulfur emitted by the burning of fossil fuels every year. However, at the same time, it could pose multiple serious physical risks and social challenges, all of which need research and study to be able to address these challenges. Nevertheless, solar geoengineering will likely be necessary to be a player within the internationally agreed upon suite of methods to address global warming. So this is new and it needs more research in both science and governance. In other words, who's going to do it? Who's going to determine what degrees we need to get to? It is not ready to be deployed at this time, and there are clear obstacles and unknowns. But the consensus of the scientific community, from what I understand, is that the sunlight scattering schemes will need to be studied, because while there are risks of deploying SAI, So far, the risks of not deploying it could be many times worse. And in order to come to an opinion about the technology, it's fundamental that the risks and benefits are weighed carefully, as there's no magic wand in this story. We are in a risk world. So these are some of the risks. The risks actually may be very large, such as the disruption of seasonal monsoonal rains, the hijacking of technology for harmful reasons. It could discourage a timely transition to renewable energy. Other countries can and probably will use this. I think there are 8 different countries studying this. And once started, it has to be maintained. And although needed, international governance and agreements to how we're going to do it and that we should do it together are actually unlikely. The upsides would definitely be large. The technology is simple and expensive and effective. It could stop the polar ice cap from melting. It could avoid drought and starvation. It could avoid the continuation of the 6th grade extinction. It could slow sea level a bit, although because of the amount of warming in the oceans, that is going to continue to rise. It can avoid mass migrations. It could prevent climate wars and save billions of people in the Southeast Asia. It could help to save the coral reefs in Amazon. It could provide global climate equity. And it would also buy us time, this is the important one, to transition to renewables and teach our cultures how to live within balance of nature, which is probably going to take a long time for us to learn. However, failure to pursue research now on possible climate interventions would deprive future generations of options to limit climate harms. So SAI is not ready for prime time as it needs research. For now, atmospheric science is so complex that our own computers are not able to model cloud behavior. We're waiting for quantum computing. And we need to address the possible risks that this technology does present. David Keith is at the Gordon McKay Professor of Applied Physics at the Harvard School of Engineering and Applied Sciences. The reason I somehow got into this is that it's right around the corner from the GSD. And when I was reading these books, I was stunned to see that this was all going on at Harvard. And he is one of the world's most influential researchers and the voices on solar geoengineering. And he's also one of the few who have done detailed engineering studies and logistical calculations on just how SAI might be carried out. In a 2014 paper in Nature, which is old by now, found that among a variety of climate interventions, only SAI was able to return global average temperatures to pre-industrial levels. That's still true. And this is an important fact. It's the only likely solution on the table that can tamp down global warming. But the greatest challenges to the successful deployment of SAI may be the social, ethical, legal, and political issues associated with the regulation of it, rather than the scientific and technical issues. And whatever one thinks about the potentials of this technology and its application, there is a need for a forum to broaden the discussion about SAI into the mainstream conversation about climate change response. And although research is unlikely to provide conclusive answers to all the questions about SAI, thorough and transparent research will put us in a better position to evaluate and make decisions about whether to intervene or how to respond to interventions by others. And without this response, I believe it is a given that the world will heat up more quickly to temperatures that will cause terrible suffering and social conflict. And it's definitely not a world where I would like to pass on to my children. So what we need is we need funding for research now. We are in a race for time. We need time to research SAI so that we are able to deploy it as soon as possible when it is needed in order to keep the Earth at its present temperature and not going past 1.5, which is highly likely. And also, the earlier we are able to deploy, the less risks there are in terms of its deployment, and the less damage would be done, like by global warming. So, as I said, there's a lot of talk about it within science, and also now has actually trickled into the US government. There are a lot of people who are very much against it, as I said, and believe that it shouldn't be researched. But, you know, I would say that from myself, the precautionary principle, that's kind of what I go for. And this is a principle in science and law. It's very old and very dense. If you want to read this, you can get it up on Wikipedia. But when it comes down to it, the short version is, in policy, you hope for the best, but you plan for the worst. So I believe it's time to start planning for the worst. So what needs to be done? Who is going to do it? Can we participate? I assume that probably most of you are thinking about this. Like, what can you do, or what needs to be done? Or it's so big, I can't do anything. But actually, it turns out there are so many things that need to be done. If you really kind of think about what your own skill sets and interests are, there is something that you could do. I mean, I decided that, well, getting to know these scientists and how poorly they're able to actually express themselves after reading article after article, I thought, well, I'm not a scientist, but as landscape architects, we have to be pretty good, and designers, architects. I mean, if we weren't good at actually interfacing with people, and if we weren't good at communications through all sorts of means, talking to people, talking to communities, drawing things, coming up with ideas, we would never get anything built, right? Because we're just designers. People are building it. They're spending a lot of money on what we're doing, but we have created trust. So I thought, okay, well, maybe I could actually do that to actually push these forward. So just to let you know, I've actually started an organization called Mayday.Earth, and we hope to tackle 2 of the 4 important things on our How to Save the Earth list I told you about. And what we're doing is to support the research on stratospheric aerosol intervention. And number 2, educate on nature-based solutions and how they can tackle climate change. So those are 2 missions. Now, before Christmas, we're going to initiate this launch of our website. So it's not quite ready for prime time. And I am going to be working on a petition actually addressed to the people of the Global South, because the people who are really against this, this idea of even research and are stopping it are people who are all environmentalists. And I understand their angst about it. However, to stop research, I don't even understand that. We may find that it absolutely is not something that we should do, but we may also find out that the risks that we're thinking of now may not be as dire as we thought. And we may feel at some point that we're in such a bad spot that we have to do it in order to do the best we can do, as opposed to just letting it rip. Now, most of these problems are happening in the Global South, but the Global South does not have a voice in this conversation, at least not yet. So that's what we're going to be working on. And if you have any interest in learning more about this, I mean, I have lots of articles we'd be able to actually send to you. And if you're interested in supporting the petition for its research, but you should know something about it, you could always give me your email. And when we finally actually mount this, we'll get back to you so you can read what we're saying and decide whether you'd like to support it or not. So thank you all for your time. I know I kind of blew over it. If you have any questions or comments, I'm happy to stay here and have a conversation. So thank you all for listening. Thank you, Tulane, for inviting me. Thanks, Jesse. Thank you, Judith. Thank you, everyone. Thank you.
Well, thank you very much, Martha, for living up not only to the fringe, but a range of, we've moved from lecture to seminar, I think, to educate all of us. And I want to turn it over now to Professor Kinnard to launch us into a little bit more focused discussion and response. Judith, please.
Well, first of all, thank you, Martha. Your passion and the depth of your research was clearly evident, and I'm sure that your students are really being enriched by this, your pedagogy that you're building. You know, clearly the questions that you raised towards the end of your talk are naturally the ones that those of us who teach in design disciplines are indeed thinking about. And so I guess my first task would be to probe a little bit more on that, because to me, the thrust of your talk is that a big takeaway I had is that since the house is on fire, designers are effectively just rearranging the deck chairs on the Titanic, and that our role as designers is pretty helpless. Now, you did pinpoint some activities as designers in the landscape realm, in particular, relative to reforestation of cities and in extreme and powerful ways. But we all know that takes enormous time and commitment. I mean, to grow an urban forest is a 20-year thing. And it's and another part of your talk sort of convinced me that we probably don't have that time. But in any event, I guess the question is, as we looked at those wonderful images of the early part of your career, as well as projects that were much more recent than that from your professional practice, the beautiful images that deal with color, geometry, formal themes that are historically the backbone of an education in design, whether in landscape or in architecture. I see a clear schism in the various parts of your career. And are there aspects that you think can bring it together, or do you see these as, is it really just the Titanic?
No.
Arrangements?
No, it really isn't. And probably I've done a disservice. I mean, if you wanted me to fiddle around, I could show you this project, but no, absolutely not. It's created a fire under us. We are working on projects. I can tell you one thing that happened. And you know what? Certainly what I went through was an evolution, kind of step by step. And kind of the more I learned about it, kind of the more I was able to kind of steer in a direction. But after having learned about geoengineering and the bigger cycles of earth science, I was getting more and more interested in bigger areas of land. And I mean, I'm still at Martha Schwartz Partners, but I've teamed up with an engineering group who don't do design very well, but they have a big staff and are very deep in engineering. And we've been working together on huge tracts of land, like the size of Belgium. And I can't show it to you because it's under an NDA, a non-disclosure agreement. And there are a number of these things happening, but I can tell you that it was for an airport. Not the biggest Belgium thing, but it was 500 hectares. I actually came up with the idea of an airport that could be a negative emissions airport, because I know about these different technologies. I mean, it's all speculative for right now, but you know what? My speculations tend to pop up in the future. So it's like, if I can imagine it, it can happen. So our creativity is absolutely necessary now. It couldn't be more necessary.
Well, I think that's a wonderful way to phrase it. I mean, certainly the hallmark of a design education is informed speculation.
Absolutely.
You talked a bit about the situation in Louisiana, and I think we are very embedded, not just in the literal place, but these themes relative to our setting. We're doing some design studios that are working on salt domes, designing and understanding that geology and its role relative to extraction and storage and many other things. And I think, of course, Louisiana is a particular case.
Yeah.
2/3 of our emissions come from the petroleum and chemical industry, oil and gas, and that is the highest rate in the country of all 50 states. And knowing the politics of our world, that is very unlikely to change soon. That said, if there's profitable businesses that can do carbon capture and sink it into those salt mines, that is something that I think has potential promise. Though whether there's a role for the design discipline in developing those kinds of
Well, there is. I mean, there are always opportunities. Again, if you have an imagination, what we did is that we decided we were going to take down not only the emissions of the takeoff and landing, but actually the trip, but it means that you have infrastructure now that needs to be set someplace within the landscape. So the other thing that we worked on is how do we make it self-sufficient? This is a very important point I didn't bring up because I don't really have enough time, but we all need to take a look at self-sufficiency for many reasons. One is that countries are going to stop trading food because we need to feed our own people within countries, and that's actually starting to happen. So we need to produce our own food for our countries. You need to make sure that we have water security in our own countries. We have to actually start to depend on ourselves and the systems that we need. So in this airport, we had a series of cycles where we took down, everything was powered by solar. We were able to clean water from city sewages because of new technologies. We were able to produce our own food for it. We were able to store the energy. We were able to regreen a very arid area in order to cool it down eventually and attract more rain. But we designed a huge earth art project using the colors of weathering rock, which in this place was very green and the other one is very red, and we painted it. So
well, this is so exciting to know that aspect of your design thinking is alive and well in this new body of work. I'd like to open up the discussion to some questions. I know that we've gone a little bit long, but I really want to give the opportunity to the folks out there to share their thoughts.
I'd love it.
Yeah, one question that came in online was that, and I think Martha acknowledged this, but I mean, this was my own critique of Martha's focus on geoengineering years past, among many of our colleagues who thought Martha was completely crazy in this regard. But geoengineering and carbon capture and storage have been advocated by, and I'm quoting here, have, quote, been advocated for by climate deniers to delay curbing emissions. How can you reconcile sharing that position, end quote?
Well, you really can't. And it kind of goes back to human behavior. And it's true. I mean, it could happen that when we start taking down carbon dioxide, the oil industries are going to say, hey, yeah, let's rip it. Let's actually keep on pumping. But if we take a look at what's happening now, we're starting to transition anyway. And it's going to take a while for these things to actually, be able to actually work. They're too expensive now. And we need a whole lot of them to really make it work. It's not working at this point. And yet, we're starting to really turn around. Oil has gone down, it comes up, but I would say that it's also very possible that we won't. You know, that there's one side of it that
Yep.
it might happen, and there's the other side is that, well, it might not. And the might not,
Precautionary
I would
principle.
actually, yeah, exactly.
Yeah, yeah,
Let's
I
give
got
it a go. We can always
Yeah, I hear you.
stop. Okay.
Nick George has his hand up. Nick. I think Nick, I think for those of you with your hands up, I think the best thing to do is to drop your question into the Q&A.
Oh, how I missed hand raising. I wish I could see people's hands.
I know.
This is sad.
It's tough.
Yeah, it's tough.
If you're still out there, Nick, just drop it into the chat. Martha, I have a quick question while we're waiting for a few people to drop in. Well, you know, you said that, I mean, I remember in 2016 when you went to the convention at ASLA and you said, you know, that's it, I'm out, right? You know, well, what do you tell young architects and landscape architects who want to get a license? What do you think? You know, what would you tell the professional? What would you tell NCAR? What would you tell the accreditors? What would you tell them to change the trajectory of licensure and of accreditation? I mean, is it about climate literacy? Is that what it is? I mean, is that what you're going to hold people out for?
Did I really say I was out? I said, we have to actually deal with climate change. Like it was a duh, like it's climate change stupid. That was all that was. Right. When I say I left landscape architecture, kind of what I did is I went on a sabbatical and I toked up, you know, I just read a lot of books to find out what is causing climate change, what's happening around us. How is it? I mean, I just kept reading. I was very curious. And the more I read, the more interesting it got. I was just hooked. But I'll tell you something, when you actually when you educate yourself, it's, you know, garbage in, garbage out, information in, information out. That's really how we work. And the more information we have, and you know what, Jesse, I think this is the most creative time I have ever lived in, where there are so many ideas being generated. I mean, the only thing that is really going to save us is the World Wide Web. You can find everything on here. It's amazing. It's amazing that it's actually happening at the same time, because we can actually get on top of this because we're all connected and there's so much going on. But in order to understand a lot of these papers and information, which a lot of them I still can't understand, but you know, you're all connected to a university. You get all these papers that people are writing. You can learn so much. I learn a lot just by giving these lectures. I don't know that much, right? So it really is about learning. And the more you learn, the more ideas you can pull together. So I really think it's just like feeding the engine. It's really simple. I really think we should learn it, you know, teach it in school. Yeah. Okay. Good news. Good news. Sorry to interrupt. We've got some questions coming in. I want to go with Z. I want to go with Z Smith first. Is Z? Oh, well, we've got Nick on. Okay. We got Nick. And then we're going to come back to Z Smith's question.
Nick's been trying to figure out how to
someone unmuted me.
We got Nick. I see Nick. Right.
Can you hear me?
Yeah, go for it, Nick.
Hi, Martha. Thank you so much for your time. And I just want to say I really appreciate you diving headfirst into this as a professional, you know, a sort of life-changing moment. But I'm a fifth-year BArch student from Lake Charles, Louisiana, entering my thesis research at the moment. And I'm interested in post-disaster recovery in terms of housing and obviously some larger infrastructural needs in the immediate and sort of long-term timeframes. But I'm a little wary because I don't want to suggest something that inadvertently contributes to climate change while trying to mitigate it. And I know you mentioned we're in a risk decision environment right now. So I was just wondering if you could expand on that a little bit more or offer any advice.
Well, I'm afraid, Nick, that, looking around my desk and kind of how I live is contributing to climate change. However, you can balance that with doing something that kind of contributes also. We're not going to be able to, whitewash ourselves just because of where we are in time. But here's the other thing, is that there is so much that architecture needs to do, so much that planning needs to do. For example, these are some of the things I think about. In order for us, and I would say also, Judith, that yeah, trees in cities are going to take a long time. It won't take a lot of time to cool down the cities if we were to take up our impermeable surfaces, which some cities in Europe are already doing, repaving it in a way where water can actually percolate back into the soil, which actually, helps to cool off the city. That any little piece of land, it doesn't matter. In one sense, it doesn't have to be about design. As long as you put some ground cover on it instead of hard surfaces, that's going to help immensely. Any surfaces of a building that somehow you can actually put greenery on can happen way before trees actually mature. But I'm working with the guy on our grant from India who is a specialist at planting forests. And he can plant forests that within 10 to 20 years are fully grown forests. That's coming out of research. There are all sorts of things. So what we're thinking about the past and how things work in the past doesn't mean that that's just how it's going to work in the future. There's just so much stuff to be able to get your hands on that can actually say, no, actually, we can start planting forests that will start to take down the heat in 3 years.
Well, I apologize if I misinterpreted some of the
No. I mean,
because
that's
I
a good
was
question.
Overwhelmed by the question of time.
Yes, well, me too, Judith. Me too. But I'm just saying, call me up. I can tell you how we could regreen our cities very quickly. And by the way, in New York City, I just gave a lecture at the Cultural Landscape Foundation. We're flooding here in New York City. Why? Because our infrastructure is so old. Now, we can do something really quickly if we were to just forget the sewer system, which is 100 years old. Even the city can't afford to do it. We can do it in smaller, different ways. We can think, we've been talking about the 15-minute city. We just gave the award, the Obel Architecture Award, which I am actually the chairman of the jury, because they wanted a landscape architect, woohoo, on an architectural award, this is how we need to start thinking together. And we have to stop these silos. It's very counterproductive. But we gave the award to Moreno, who started this idea of breaking cities into smaller pieces, where we could actually be more self-sufficient, be more active to be able to deal with climate changes. We are kind of getting all the cars out of cities. That's what's happening. So the whole discourse about how we actually redo our cities is brilliant. It's so energized. And these are things for planners. We do have to, okay, so here's a question I have for you guys. In order to cool down cities, in order to be able to take enough water from our storms and actually both not have it flood the city, but also keep it so that in times of drought, because it's an irregular climate, how do we get the city to do it? It's not going to do it. So how do we do it in smaller pieces? So the idea of actually using different kinds of new ideas and new technologies, stormwater management devices that every person in the city can put next to the house. And, you know, there are these smaller, more granular ideas. So we need more land in cities to actually provide these ecological services. Otherwise, we don't survive. However, to do that, we need, you know, super tall buildings. And actually, IIT asked me to be on this panel for super tall buildings. I said, well, I'm not an architect. I said, yeah, well, that's why we're calling you up. So how do we actually make that work? And then how do we make those materials that we need? We still need buildings. We still need to live in buildings, but the distance between the architectural profession and the profession of landscape architecture is huge. And
well,
yeah, so that's
Martha, in the interest of time, I apologize for interrupting.
Yeah.
I do want to get to as many people as possible. I want to open up to our faculty colleague, Margarita, who's really one of our, I think, one of our leading experts at this school. And Margarita, I think you have the mic now, if you can get through.
Okay, Margarita. Okay.
Hi, hello, Martha.
Hello, Margarita.
Thank you for first of all for the lecture. Have 3 questions on the chat, but maybe the first one will be the second one, which is I'm sure you know the project of the North Sea, the energy transition North Sea, that is a communal project of the European Union putting together, I think it's 5 or 6 countries.
I actually have heard about it. I haven't read about it. So
yeah, just thinking about a combination of a strategy like this one for Louisiana with a green infrastructure, as you know, at a large scale, like the one in Melbourne, Australia, etc. Yeah. To as a first front line before opening up the door of geoengineering, but because of political reasons. We seem not to be ready, perhaps, for this, in my opinion, for a transition that you know, keeps hands clean for polluters. You know, so yeah. And I would like to know how that can happen, and what is the worst case scenario if we don't make geoengineering. You already explained it, and we invest in green infrastructure. Do we have 10 years of worst, you know, climate and then recover? What is going to look like the curve? Or is, you know, the hypothesis of implementation of different strategies in the long term can be interesting area of study.
Margarita, I can't answer it. Yeah. And I'll tell you why. Because we have a lot of ideas. We know what we need to do. I mean, you know, if you read the science, you know, that's pretty good stuff and pretty reliable. We know we have the science, we have the abilities to do this. You know what the problem is? Our people. Like, we all have to, I mean, it's about our personalities, our ethics, our beliefs, and whether we're optimists or pessimists, really. I'm actually an optimist, but I'm thinking you have all these guys who are leading countries. I'd feel a lot better if we had few more women in the discussion about leading these countries. We're still after power and money. China's going to just keep on going so that it can keep its 10% GDP and keep on digging these coal mines. Yeah, it's a crapshoot. I don't know. And I think, you know, like the US is not reliable. We could have Trump in the next few years, again, go backwards, which is really a tragedy because we're wealthy enough and big enough and creative enough to come up with fantastic ideas that could be done. Absolutely. So yeah, we could do this and we don't have to use geoengineering. Absolutely, we don't. But it's all up to whether we can work together globally or across purposes, or we are lucky and have good leadership and we're actually going to be spending money on trying to save the earth, or we just want to get more cars and I don't know, consume more? I don't know. I don't know. I don't think anybody knows.
But it's encouraging your energy. It's really great. Thank you. Thank you.
Well, I think it's all hands on deck, Margarita. We need to do, I'm energetic because I feel like I maybe can contribute something to it. So,
well, as we wind down, I think it's really, I'd like to just kind of arc back to thanking you, but also to what Nick George was asking about relative to a thesis student. You know, I think one of the things that your lecture was so great for is motivating our students to think big. And the thesis moment is a great place to speculate without, in a fairly risk-free environment where you can bring issues to the fore that you may not be able to fully resolve. And I think that your adventurous spirit really, I'm sure, motivated a lot of our students today, Martha.
well, thank you very much. I mean, we all have so much to contribute, and I know how everybody feels. I mean, at the beginning of this, it's like, Jesus, how can I do anything? But, you know, after thinking about what you like to do, what you can do, what you're good at, what you're interested in, you finally kind of start chewing on stuff. But I'll tell you that my real thing is about urban afforestation. That's what I'm researching at Harvard now. And we're actually going to be doing a pilot project. It's based on the idea that, you know, we're going to have automated vehicles and probably can harvest 35 to 40 or even 50% of road areas, that we could plant real forests in a trench with kind of, you know, stormwater management and eventually cool down cities. So that's what I'm really working on. I mean, I'm just kind of let's really think about these other solutions that we may need and at least know about it.
Well, listen, I want to thank Martha, Judith, Margarita, everybody who's chimed in, but really, Martha, thank you so much for joining us tonight. For the record, I actually did get the introduction correct, but Martha was so convincing in her performance that I had introduced the wrong Martha Schwartz that some people in the chat believe that. So Martha, you're both an inspiration and a true talent for your acting capacity. So thank you for that. And listen, next time we hope to get you down to New Orleans, and then we'll be able to review somewhere along the way.
I will come. I would definitely come. And Jesse, I miss you. And thank you all. Thank you for spending your time with me. I would sit here all night if you wanted to talk, but get me down to New Orleans. I'll be good. Okay.
All right, thanks. Good. Well, listen, next week, everybody, we have Washington Fajardo, who is the city planning commissioner of Rio de Janeiro in Brazil, is going to join us for the next installation of our fall series. But thank you again, Martha. Thank you, Judith. Take care, everyone.